if you decide to do something, you do and go ahead with that and never have regrets about that decision. I planned my lab around $500,000. I should warn, never come to research.
So hey guys, welcome back to this YouTube channel. I am Gopal Kulkarni. I welcome you all in this new series of interviews with scientists, Sci-Insights with Gopal. Today we have our first guest as Dr. Rajeev Kini sir. He has done his PhD in University of Nottingham, studying the acoustic photons, and also his postdoctoral work in the spintronics of semiconductor in Virginia and Colorado. He is the winner of Kerala State Young Scientist Award in 2014, and currently he is working in IISER Thiruvananthapuram, working on the light matter interaction in quantum world. So welcome him, and we'll start the interaction. About your educational background, sir. Tell us about your journey from being as a college student or a school student and being a scientist and working at a lab and your own research at IISER now. About your journey from this.
Well, I'm from Cochin, and so I had my schooling in Cochin. So until my 7th standard, I studied in a school called Cochin Gujarati Vidyalaya, Sri Cochin Gujarati Vidyalaya, and after that, I studied my high schooling in Tirumala Devasam High School. Okay, and as I was finishing the school, I was interested in science, and then I joined a college. So those days, this +2 level was also in the college, and it used to be called the pre-degree. So I did, this +2 level, that is pre-degree 2 years, and then BSc Physics in the same college. It's called the Cochin College. So 5 years I spent there. So I took the science stream for this +2 level course, and I have some problem with memorizing things. So of course, biology and chemistry, that way I had to rule out. I liked maths and physics, and most of the things, if they were logical, it's easy for me to, grasp. And this abstract things was not my cup of tea. So obviously that meant that I had to take physics, and I liked physics. So I went on to do a BSc in physics. The joke is that as I finished my +2, I had good marks in chemistry and maths, and I had the least marks in my grade card for physics. So I thought then I should continue and make it better in terms of physics. And after that, as I finished the BSc, my teachers kind of introduced me and told me that there is I should try IIT Madras or for masters. And I wrote the entrance exam. I got into IIT Madras for my MSc. As I was finishing MSc, from the campus interview, I got a job offer from Infosys. So in between, I spent 1 year in Infosys, learning software engineering and all that. And after that, I went to UK for my PhD. I did my PhD in Nottingham. As you just said, I worked on photons in semiconductors for my PhD. After that, I went to Virginia Tech. I spent a year there looking at some problems in spintronics, and then I got an offer from National Renewable Energy Lab for a second postdoc there. I spent 3 years there, and then for the past 10+ years, I've been here in IISER TVM. I have a group of my own where we look at ultra-fast studies and so on. And as you know, I teach here, so it's a teaching and research profession going together. Yeah. So that's the brief about my journey from a student to a researcher.
So, what was the factor that motivated you to be interested in science or to become a researcher? Because as you said, you had the job at Infosys, such a big company, and then you turn your interest in researching and all this scientific journey.
One of the things that this research field gives you the freedom, right? You're your own boss and you choose the problem that you like to do, and you pursue that. And that I don't think is there in any other profession. So essentially, you are getting paid to follow your hobby, right? So so you get a salary, and then you do what you like. So essentially, that is one of the things that pins me down to this profession. And add to that this academics and teaching, which makes the life a lot more lively, because every year or every semester I teach a new batch, and all these bubbling young kids keep myself also young at heart. So that's something which keeps me to this field.
Yeah, that's nice. Okay. So, and what was the factor that motivated you towards physics? Many students find the physics as a difficult subject, or they just memorize the formulae. So, what was the factor that you started understanding it and the conceptualized part of it? So, how will you define that part?
So yeah. So as I said, as I was finishing school, I wanted to go into science. So when I told this at home, the first advice that I got, because in my family everyone is a commerce graduate. My cousins, my brother, my uncles, everyone is a commerce graduate. So the first advice that I got is, you can do whatever you want, but if you take science and you have some doubts to clear, you will not be able to come to us. We will not be able to help you. But I went ahead. I did, but I joined this +2 course, and it's a government aided college, lot of strikes and all that. Okay, so a lot of classes get cancelled and all that, and I didn't have a possibility of getting private tuitions also. So most of the studies, I would pester teachers and ask them to teach me all that, and most of it, rest of it was self study. And I found that physics was more easy for me to understand because it made sense, right? It's more the it made common sense. If you have some common sense, you can make sense out of whatever you are learning. So that is why I went into physics. And many of the when I was a +2 student, some of the experiments that we did in lab, so I would try to set it up at home also. For example, like the PV experiment and force, the addition of forces and all that. So I would, those are simple experiments, and then I had kind of a lab in my home where I would set up all these things. So I like this tinkering business. So I even had a small lab where I would make this electronic circuits and small things with that. So that is how I actually got interested in physics and in that sense research. So that is why I kind of pursued that. And as I finished my +2, most of I don't know across, but in Kerala, like if you're doing good in your studies, the first choice is you write an entrance exam and then go for engineering. But for me, I think I had a very clear decision. I didn't even write any engineering entrance. I just joined for BSc Physics. So that was surprising to my friends as well as others. So I asked one of my teachers, and the advice that he gave me is actually, if you decide to do something, you do and go ahead with that, and never have regrets about that decision in future. And to be honest with you, I don't regret about that. I'm quite happy that I made a decision to go and pursue physics, and I'm much happier than what I would have been if I were pursuing a BTech or an engineering degree.
Yeah. So currently, what is your lab working on? Which questions your lab is working on, and how will you explain that work to a undergraduate student or a +2 level student in just simple manners?
So my lab, in a broad terms, we work on very fast processes that go on in a material. Fast in the sense, if you look at the time scales, in general time scales, you talk about milliseconds, microseconds, and then if you go further, you have nanoseconds and picoseconds and femtoseconds. Now there is even research going on in the time scales of attoseconds. So our lab is mainly looking at processes, things that go on. If you take a material, for example, if you take a solar cell, right? So light falls on it, and then it creates electron hole pairs, and you take out that electron and get it to flow through a circuit so that current is generated. But from that light falling and the current generation, between that time, a lot of things go on, and all these processes happen on a very fast time scale. It's of the order of picoseconds and femtoseconds. So essentially, our focus, the focus of our lab currently, is to study, understand these kind of processes in different materials. So that is what I would say, a broad. So there are different problems that we are looking at. One, if you ask me, it's easy to understand, would be we are looking. So a +2 level student would have actually come across different kinds of particles like electrons, photons, and so on. So currently we are looking at a particle or experimentally realizing or experimentally visualizing a particle called photon. So this is actually a hybrid of an electron and a two-level system. Like in an atom, you have a 1s and a 2s state, right? So that forms a two-level system, and an electron actually combined with this form a quasi-particle. It's not a particle like an electron, but it's a quasi-particle. It has the properties of a particle. So we are trying to look at experimental signatures of this quasi-particle. So that is one of the problems. And for example, we are looking at different kind of materials, like people would have heard about graphene, right? So this is layers of carbon, and you can use a simple technique like you use a Scotch tape to exfoliate these into thin layers, mono layers. So there is a lot of different materials of which are very similar to graphene that has emerged in the last 10 years or 5 years, which have different interesting properties. So we are also looking at some of these called transition metal dichalcogenides, using of course using optical methods.
Yeah. So what are now your future plans about this research, and any planning to collaborate with any others, your aspiring scientist or something? What are your future plans?
Most of our work involves a lot of collaboration. So we do some part of it, like the experimentally looking at some of this, and we do have collaborations with people in India, even in our institute, and also abroad, who look at the theory, and some of the people who actually make these structures. So we design these experiments, and somebody else makes these devices, and we do the experiments. Another group will do the theory, and so on. So we do have a lot of collaboration. So we have a group in Australia with whom we are collaborating, University of New South Wales. We have a couple of groups in UK, which is University of Nottingham, University of Bristol, University of Sheffield, and then in US also we have a couple of other collaborators with whom we work. And again, in India, we work with people from University of Calcutta, SN Bose Institute, our own colleagues in physics and so on. So, it's always a very big team effort when it comes to problems like this.
So, sir, what were the challenges that you faced in this complete journey also as being a scientist, like financial or some supporting problems, and also in the research part, like the funding of the research or the quality of instrument that specifically in India that you find that you will find better in abroad or something like that. So, what are the challenges that you face in this?
Really, I mean, this funding is an issue. It's difficult, but that is the case with any other place. I mean, not just in India, right?
Yeah.
So to give you an idea, so when I was actually coming back to India, so I had no idea, how much money I would be able to secure, and how I will set up the lab and so on. So when I was offered this position here, I called up the director and asked him, like, what do you, what will you offer me? How much money will I get to set up the lab? Okay. So the way he put it is that, Rajiv, you come up with a plan, and even if you come up with a plan for $500,000, okay, we will provide you that. Okay.
Yeah.
So I went ahead and planned my lab around $500,000, and to be honest with you, I got it when I came here. Okay. Not necessarily that is the case now, because that was the initial time when the institute was just coming up. Okay. Right now, we are in a very difficult situation with the funding, and I have, as I said, very good instruments, but maintaining those, it's all expensive instruments, and maintaining and finding funds for maintaining is a difficult task, but it's still manageable. One can do that. Okay, so money is one aspect of that. Student wise, we get very good students, of course, right? And so that is never a problem. And the quality of instruments, any instrument you get abroad, you can get the same thing here. There is no issue with that. And in that sense, I can very confidently say that if you are doing a PhD abroad or here, there is no compromise in the quality of your of your research. So it's a question of how well equipped you are, how equipped you are with your ideas. It's only the ideas that actually drive the research, right? If you have a very good idea, I don't think there is any issue in pursuing that in India.
No. So how will you describe the positive parts or the perks of being in a research field for aspiring students? So those are aspiring to get admission into IISER or any research institute. So how will you describe those things?
As I said, one of the biggest things that actually attracted me to this field is the freedom, as I said earlier, to do whatever I like, right?
Yeah.
So I pursue an idea, and 2 years later I feel that it's getting boring, I'll switch over. So when I came to IISER, we were working on something called dilute bismuth. It's like you add an atom of bismuth or few percentage of bismuth to gallium arsenide and see what happens to that. So it's a band gap engineering problem.
Yeah.
I worked on it for some time till 2 years ago or so. Two of my PhD students work on it, and I said once those two were finished, I said we will no longer work on it. We will move on. So we had enough of that. So that's the freedom that it's giving me. I can pursue the idea. Nobody is telling me that you do this. Tomorrow you come to the office and you start doing this. Nobody tells me that. So that's the freedom that gives me because of this field. The other one, I like traveling, and because of this research, I get to travel a lot. So there is a funny incident. Once I was going to I think US during my postdoc time, and then I was at the airport and somebody looked at my passport. There were several visa stamps on it, and that guy was surprised. He was asking me, "Oh, sir, are you a journalist or something? Do you travel a lot?" So I said, "No, I'm a researcher, and I get to travel." And again, it's not from because you every year you travel and you present your results in an international conference, right? So that is a advantage of being in a research field. That is one of the fun things that you get to do, right? And again, when you are in academics, meeting very young kids is always an interesting part. And when you go and teach, you get so much of questions which even you would not have thought about, and that keeps life very interesting. So that is something, if you like all these things, again, research. But I should warn, never come to research for money, right? Research is not the field where you want to actually mint money. You cannot do that. If you are looking for a high flying life with luxury car and all that, that is not what research is meant for. It gives you a comfortable life. The life is really comfortable. At the same time, you have happiness in your life. Yeah.
So, as a societal picture, a scientist is considered to be a lone person, that he continuously works in his hand. He doesn't have any personal life, as normal people, that non-science people think. So how will you describe your work-life balance, and also the balance between teaching and research? So how do you balance between them?
Well, personally, I have diverse interest. Okay, so not just research. I get involved with a lot of other things, but I spend a lot of time in the lab and then in the institute, which does affect this work-life balance. And I get most of the time complaints from my daughter saying that I don't spend enough time with her. So the way I try to do is actually I kind of wrap up most of the things that needs to be done for the research in the 5 days a week. Okay, and so that I can spend the weekends with family. And apart from research, I keep some other interest in so I kind of am involved with some of this art organization like SpeakMake. So I spend some time for that also, and that way life is never boring, right?
So it was a nice pleasure to interact with you, sir. Thank you for giving your valuable time to us. And special thanks to Akhila also. She is coordinating this meeting and also for recording and all that.
Thank you, Gopal. Thank you, and thank you, Akhila, for this wonderful effort. Okay.
Yes, sir. Thank you for taking your time for this.
Bye.